Hello everyone, in this video I'm going to take a look at another example of solving some differential equation using the method of separation of variables. Okay, so I'm going to keep it relatively simple. Let's consider dy dx equals minus y divided by x. So we want to find the function y, which is a function of x. Okay, so what do we need to know? Separation of variables. There's a general form, dy dx equals some function of x, say f of x, times some function of y, say g of y. And from that, we're going to collect all the y's on the one side. So divide through by g of y. And then we're going to integrate with respect to x. And from that, we should be able to find our answer. We should be able to solve. Okay, so in our case, dy dx minus y, let's just tidy that up, minus y over x, and we want to separate the x's and y's. So a few ways to do this. I think I'm going to write it as minus 1 over x times y. There's a choice with the negative sign. You could put it on the y, or you could put it on the 1 over x. It's up to you really, no big difference. I think I'm going to keep it on the 1 over x. So I'm going to keep the y clean when I take that over to the left hand side. Okay, so let's do that. Let's move the y to the other side. Just before I do that, let's just highlight this is our f of x and this is our g of y. So move the g of y over by just dividing through. Okay, and next we want to integrate. So let's do that. So we integrate both sides with respect to x. What do we get? Well, as usual, the x's cancel like so. So integrate 1 over y dy dx, integrate 1 over y with respect to y. This is a standard integral. This is log of y. Derivate the right hand side. Integrate minus 1 over x, or 1 over x integrates to log of x. Let's pop the minus there, and we want to add our constant of integration, so plus c. Okay, so that's what we get from integrating. Doesn't look ready at the moment. It looks like we need to use some algebra to tidy this up. So let's do that. The best way to do that, let's have a think about this. We could take e of both sides, that would work. Or we could collect the logs together on the left hand side and use the rules of logs. I think that's better. I think that's going to be a little bit cleaner. So let's try that. So start a clean page. So we have log y equals minus log x plus c. Collect all the logs on the one side. So the rule for logs, sum of two logs is the log of the product. Okay, that's looking much better already. So to remove the log, take e of both sides. We have x times y is e to the c. I think I'm just going to give that a new name. It's just some number. I'm going to call it a. So finally, y equals this constant a divided by And there you go. There's our general solution to this problem. Okay, what about the geometry? What do these things look like if we were to draw them? Well, if a equals 1, a simple case, we would have y equals 1 divided by x. So we cannot put x equals 0 into this equation. We're going to have this kind of curve when x is bigger than 0, and this kind of curve when x is less than 0. Okay, what about other values of a? Suppose we chose 2. Well, not a lot's going to change. We're just taking this graph on the left hand side, and we're doubling all the values. So actually we're taking our 1 over x and we're doubling it. So we're just going to get something maybe a little bit steeper, very similar shape. And so on and so on. Different values of a are just going to make that a bit sharper. Okay, so there you go. There's our next example of solving differential equations using the separation of variables method.